looking at the second quadrant of a unit circle. This is the second part of a series of 4 videos about the unit circle. So we've already looked at the first quadrant and we looked at how the ratios of sine, cos and tan are related to the x and y variables. So when I draw a line out from my unit circle to the edge of, from the center of my unit circle, which is the origin on my graph. Okay, so we've graphed a circle on a set of axes. And so from the center, from the origin out to any point on the edge of that circle is exactly 1 unit. Okay, which is why we call it the unit circle. So when we've done that, we've found out that if we measure an angle of theta, and remember that all angles are measured from the positive x-axis. So when we're talking about measuring the angles, we always sort of start from the x-axis. Okay, sometimes we start from the other side of the x-axis, but the angle is always measured from the x-axis. Okay, so we're either measuring from one side or the other. If we just have an angle of theta, it is measured from the 0 point. If we talk about an angle of 180 minus theta, then we are actually talking about a triangle where we've measured from 180 degrees, so the negative side of x-axis. So we're measuring from here, we're measuring an angle of theta, which is written in there. But when we talk about the size of that angle, we will refer to it as 180 subtract theta. Okay, so we actually always measure our angles from the x positive side, or we think about our angles being on the x positive side. So just hold that thought for the time being. Okay, so we've got this triangle that we've drawn. The angle inside our reference angle is called theta. And we can see that if we're looking at sine, cos and tan, we're going to get some slightly different values for x and y. So we know that normally in the first quadrant, sine of theta is equal to y, cos of theta is equal to x. And we'll just look at those for now. When we're talking about the size of the angle in the second quadrant there, instead of writing sine of theta, you'll see it written as sine of 180 subtract theta. Okay, so the labeling of that angle is no longer sine of theta, because theta is always measured from our x0. You can see the 0 degrees here. When we're measuring our angle from this side, we start from 180 and we either add on to that if we're going into this quadrant. All right, so this would be 180 plus theta. But we're only looking at the second quadrant at the moment. So in this case, we look at 180 subtract the size of theta. But when we're talking about sine, cos and tan, we always refer to the angle that we get when we start at x is 0 degrees. Okay, so that's why we can talk about the angle theta here, but in fact when we're writing it and thinking about it, we're actually talking about the sine of the angle that is 180 degrees subtract theta. Okay, so if I'm looking at the sine of 180 minus theta, it's actually going to be the same as if I had drawn my angle theta here, and I've got my x and y over this side. Remembering that sine of theta over here is the same as y. Oops. And cos of theta is going to be equal to x. Now, when I'm on this side, I've really got a triangle that's exactly the same as that, but now I'm no longer in the positive first quadrant. Now I'm in the second quadrant because I've gone past my 90 degrees. I've drawn this angle up from the negative axis, and the equivalent of that angle is this. So this tells me that I'm in the second quadrant, which means that my x value is not going to be the same exactly. It's going to have the same numbers in it, but it's not going to be positive anymore. It's going to be negative. This doesn't affect sine, of course. look at my y value for sine, my y value for sine on both sides here, my y value for sine is going to be exactly the same. So when I'm looking in the second quadrant and I'm looking at sine of an angle, that angle, the value of sine is going to be exactly the same as if I did sine of theta. Those two things will give me the same answer. However, if I do cos of my angle here, not cos of theta, remember that we're always measuring from the 0 of the x-axis. So when I'm referring to that angle, I'm actually talking about cos of 180 subtract theta. But the equivalent of my statement is going to be the same as, once again, this distance here and this distance here from the center of my circle. Both those distances in magnitude are the same, except that x on this side is positive, whereas x on this side is going to be negative. So my answer is going to have the same numbers in it as it does with cos of theta, except that the value is going to be a negative value. So I can say that the cos of 180 take theta, which gets me into that second quadrant, is going to be the same as cos of theta, except the answer is going to be negative. And same with tan. Okay, when I'm looking at tan of theta equals y over x in the first quadrant. But when I'm talking about tan of 180 subtract theta, I'm now pushed into that second quadrant. But the value of tan is going to be the same as if I do tan of theta on this side, except that here, my y value is still positive. So y is still positive. But over here, underneath, my x is negative. Oopsie, my pen's not working. My x is negative. So that, in fact, my answer is going to look exactly the same as if I did tan of theta. Sorry. It's going to look the same as tan of theta, except my answer, again, because I've got a positive here, that's a positive number, but this is a negative number, my answer is going to be negative. So when we're looking at the second quadrant and we're thinking about our cos, sine and tan ratios, in the first quadrant, all our values are positive because x and y are both positive. So everything, sine, cos and tan, when I divide x by y, when I divide x by 1, when I divide y by 1, all my values are positive. Okay, so we say that we call it A, all are positive. In the second quadrant, using S for second, sine is the only thing that's going to be positive. So that's a look at the unit circle in the second quadrant.